Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
All right. Today, we're diving into something that's been generating a lot of buzz lately: competitive programming with large reasoning models.
Competitive programming with AI. Sounds like we're automating the already overly complicated.
Aha, potentially. But it's more than just automation. I think it's a window into how well AI can actually reason, not just regurgitate data. And that's the interesting bit.
Exactly. I think it's a fascinating area. The idea that a machine could truly reason in a way comparable to a human brain is both exhilarating and daunting. We're seeing large language models tackle complex algorithmic challenges, which prompts the question, are they actually understanding, or just really good at pattern matching?
I'm leaning towards understanding, or at least something very close to it. I mean, look at the efficiency and adaptability displayed by some of the winning strategies in these competitions. It's remarkable. They're not just memorizing solutions, they're generating novel approaches.
Novel approaches, maybe. But are they truly reasoning? I'm skeptical. It feels more like advanced statistical analysis applied to code. They ingest massive data sets of code examples and learn to statistically optimize for specific problem types. Is that intelligence, or just a very sophisticated curve-fitting exercise?
That's the million-dollar question, right? I think a lot of it comes down to representation. How is the AI representing the problem internally? Current deep learning often feels like brute force. Can it translate the problem into a different coordinate system where the solution becomes obvious? Because humans do that all the time.
Yes, and that touches on something crucial, frame dependence. A recent DeepMind paper highlighted how the very definition of agency shifts depending on the framework used to describe it. This seems fundamental in how humans reason and how we can improve AI's reasoning. We're talking about needing to explicitly model different reference frames, not just in the environment, but also in the agent's internal representation.
Frame dependence, interesting. I wonder if that could eventually lead to more efficient algorithms for deep learning by explicitly considering the different frames in which data is represented. Could we potentially reduce the data requirements for reaching comparable performance levels in various tasks?
That's a good point, but I still think the reliance on massive data sets is a fundamental flaw. It suggests the models aren't learning the why behind the what. A more neuro-symbolic method, combining the strengths of neural networks and symbolic reasoning, would likely achieve better generalization with less data.
I agree with the neuro-symbolic angle. Think about it. When we solve a competitive programming problem, we often start by translating it into a mathematical abstraction or visualizing it in a different way. That's a change of coordinate system, a frame. Current AI struggles with that.
Right. It's about building a more adaptable, biologically inspired system. The brain continually adjusts its structure and function. Existing deep learning models are relatively static. How can we incorporate those principles of neuroplasticity and dynamic systems into AI?
But isn't the trend moving towards even larger models? The success of these large language models seems to suggest that scale is a key factor. More data, more parameters, better performance. It seems like we're on a path to AGI, even if it's a bit brute force.
That's what worries me. It's like saying if we just throw enough money at the problem, it'll solve itself. But intelligence isn't just about computational power, it's about understanding and representation. We need to focus on building algorithms that can reason about the world in a more abstract and flexible way.
Exactly. It's about the algorithm's ability to form a cohesive representation of complex systems, understanding the spatiotemporal aspects of the world. Deep learning is great at pattern recognition within a fixed frame, but struggles when the frame changes.
It's almost like we're optimizing for the wrong thing. Current AI approaches often overlook the fundamental importance of embodied cognition. How can we integrate sensors, actuators, and a physical body into AI models in a way that fosters true intelligence rather than just pattern recognition? It needs a body to experience the world like we do.
Okay, but let's be practical for a second. Even if we acknowledge the limitations of deep learning, it's still producing impressive results. These models are solving complex problems, and they're doing it at a scale that was unimaginable just a few years ago. Surely that's worth something.
It's worth something, sure, but it's not a sustainable path to AGI. It's like building a house out of playing cards, impressive, but ultimately fragile and lacking a solid foundation. We need to build upon the foundations of neuroscience and symbolic reasoning if we want to create truly intelligent systems.
I agree. The playing card house is a great analogy. The current coordinate system for understanding the world might be non-obvious and maybe even emergent. If we don't understand how the mind works in its own coordinate system, how can we build an AI that does?
And this brings us back to frame dependence. The DeepMind paper's analysis of agency seems surprisingly agnostic about the mechanisms underlying it. Focusing on the formal structure isn't enough. We need to understand the underlying biological processes that give rise to these different frames.
So you're saying we need to look deeper into the neuroscience to understand the actual biological processes that underpin intelligence?
Precisely. The potential for combining neuroscience with AI isn't just about mimicking the brain. It's about understanding how the brain works. This includes the intricate interplay of electrical and chemical signals, the role of glial cells, and the emergent properties of neural circuits.
That's where neuro-symbolic approaches come in. We can use insights from neuroscience to inform the design of algorithms that combine the strengths of neural networks, pattern recognition, with symbolic, reasoning, logical inference. This could lead to more robust and generalizable AI systems.
And it all ties back to spatiotemporal understanding. How does the brain represent space and time? How does it translate between different sensory modalities? How does it build an internal model of the world that allows it to make predictions and plan actions?
Okay, I'm starting to see the limitations of the purely deep learning approach, but where do we go from here? What are the concrete steps we can take to move beyond brute force and build more intelligent machines?
I think a crucial next step is to shift our focus from massive datasets to smaller, more focused datasets that embody core cognitive principles and are amenable to rigorous analysis from a biological perspective. We need to understand why certain data representations work. Not just that, they do work.
Agreed. We need to develop more sophisticated methods for knowledge representation and reasoning. This could involve incorporating symbolic logic, Bayesian networks, or other techniques that allow AI systems to explicitly represent and manipulate knowledge.
For me, it's all about developing algorithms that can translate between different coordinate representations. We need to find a way to teach AI to see the world in different ways, to extract hidden patterns and symmetries, and to build an internal model of space and time.
And from my perspective, we need to continue pushing the boundaries of deep learning while also exploring these alternative approaches. We shouldn't abandon the progress we've made, but we should also be open to new ideas and new architectures.
Exactly. We need to see these different approaches as complementary, not mutually exclusive. Deep learning can be a powerful tool for pattern recognition, but it needs to be integrated with other techniques to achieve true intelligence.
So, future research directions? I'd say we need to focus on developing neurosymbolic algorithms that can learn from smaller datasets, represent knowledge explicitly, and reason about the world in a more abstract way. We should be looking at how the brain represents and manipulates information, and using those insights to inform the design of our AI systems.
I'm interested in exploring algorithms that can learn to translate between different coordinate representations. How can we teach AI to see the world in different ways, to extract hidden patterns and symmetries, and to build an internal model of space and time? I think that's where the real breakthroughs will come.
I'm still a believer in the power of scale. I want to see what happens when we train even larger models on even larger data sets. But I also recognize the need for more sophisticated architectures and learning algorithms. I'd like to see more research on attention mechanisms, memory networks, and other techniques that can improve the reasoning capabilities of deep learning models.
And I'm focused on the biological side of things. I want to understand how the brain represents agency, how it translates between different frames of reference, and how it integrates sensory information with motor control. I believe that a deeper understanding of the brain will reveal novel computational principles that can be used to build far more intelligent machines. It seems like a much more concrete and detailed look at the neural mechanisms of attention, memory, and decision-making is necessary to unlock the door to AGI.
Interesting perspectives, everyone. It sounds like we all agree that while deep learning has made impressive strides, it's not the complete answer. We need to combine it with other techniques, draw inspiration from neuroscience, and focus on building algorithms that can truly reason about the world.
Exactly. It's not just about building bigger and faster computers. It's about building smarter algorithms that can understand the world in a more profound way.
And about understanding how we understand the world. It feels like we need to get in sync with the universe to truly understand intelligence.
Absolutely. The biological context is not optional, it is fundamental. If we can map agency to specific neural processes, we could start to engineer agents that are more like human beings rather than just statistically optimized algorithms. Well, I think that's a great place to wrap things up for today. Thanks for joining us on this exploration of competitive programming with large reasoning models.
Yeah, it's been a fascinating discussion. Thanks for sharing your insights, everyone.
My pleasure. Always stimulating to question the prevailing paradigms.
Likewise, until next time, keep pondering the spatiotemporal.